We're going to have a chat on streams as the final keynote or final talk. And today we've got some team members from VMware and Erlang Solutions being represented today. And from VMware, we've got Karl. If you don't know Karl, he's part of the core team. He's done a lot of work on Quorum queues, the whole wrap stuff, and that's Karl. And lately, he's also been working on the stream implementation as well. Karl.
Yes, that's right. I've been working on streams and Quorum queues. I think introduction pretty sufficient there. Thanks.
All right, cool. And then we've also got Diana. Diana, also part of the core team, and also working on streams. And personally, I had a privilege to work with Diana a couple of years ago, and it was really cool. Diana, just a hi to everyone.
Hello, everybody.
Okay, and then we've got Arnaud, and Arnaud is also part of the core team. Also, been working on the streams implementation. Gave a keynote yesterday, which was really, really awesome. And Arnaud.
Hi, everyone. Thanks for being here.
Yeah. And last but not least, we've got Gabor from Erlang Solutions. My colleague, former colleague. Gabor, any words?
Everyone, and I forgot to introduce me and tell that I'm working as a RabbitMQ consultant. I work with a lot of clients and see a lot of use cases, design systems around that.
Cool.
Thank you very much for being part of the panel.
Yeah, nice to have you, Gabor. So we're going to have a panel discussion. So I'll basically throw a couple of questions to the panel. They're going to share their thoughts, and of course you're free to also throw some questions on the chat on the Uber app. So the first question is for Arnaud. So Arnaud, just for those who don't know, and probably those who didn't hear your talk yesterday. So what are streams in RabbitMQ?
So just in a couple of words, streams are a new type of data structure in RabbitMQ. So they're going to be in RabbitMQ 3.9, and they are still about streams are still about publishing and consuming messages, but their semantics are a bit different from the queues that we have for a long time in RabbitMQ. Basically, it's on the consuming side where streams have what we can call non-destructive consuming semantics. So it means that when you read from messages from a stream, you don't remove them from the stream. They are still there. Whereas with queues, consuming actually is destructive. It removes messages. So this is the main difference, I would say, to remember. And on the more conceptual way, streams are actually, they model an append-only log. So again, it's very different from a queue actually in the semantics.
Okay, yeah, I guess that's also answered my my next question, like on what are the key new features which streams introduce.
So this the main difference from the application developer point of view is this difference in the consuming semantics, but it actually means a lot because some use cases will be handled much more easily with streams than with queues. For example, large fanouts. With queues, you need to, if you want different applications to read the same messages, you need several queues. You need to bind them to the same exchange, and then messages will be routed to all these queues, and each application will consume and process messages from its own queue. So with streams, it's going to be simpler because you're going to have the stream and applications will just attach to the stream at some point, and they can read and reread the messages. They are not competing in this case.
Yeah. Okay. Okay.
So something also quite different from queues is we can say also that streams are a bit more opinionated than queues. They are persistent, replicated, which is not the case for all the queue types that we have or flavors that we have in RabbitMQ.
Okay. Okay. Now, interesting. So yeah, probably a question from me as well. Just regarding the large fanouts. So by large fanouts, you're referring to many queues binding to a single exchange, right? So it's not really large fanout by cluster size, is it? No.
What do you mean cluster size?
So what I've noticed is that with the fanout, if you're going to have many queue leaders or many queue masters residing on many nodes, right? The bandwidth utilization gets quite high.
Exactly.
Yeah. Okay.
Queues are quite cheap in RabbitMQ, but not that much. So we have a better usage of resources for this kind of scenarios with streams. This is more flexible, more optimized. So this is one use case where streams are quite good or better than traditional queues.
Yeah. Wow, that's really cool. Yeah, that's awesome. Okay. Next question. That's for the Erlang Solutions RabbitMQ expert Gabor. I know you work with a lot of big companies and you do a lot of consulting work. So from your perspective, in terms of the field work, right, what possibilities do you think streams open up when it comes to, engineers like yourself designing and implementing messaging systems? What doors are being opened now with this new feature?
Yes, I think streams open up a different mindset for messaging. The biggest difference is not just that it supports large fanouts or bigger throughput, higher throughput, different kinds of messaging semantics, which we all heard about in the previous sessions in the last 2 days, which is all great. But it opens up something that was never possible in RabbitMQ before, which is seeing the history of a queue, history of the events, which is a completely different mindset. Previously, if you published an event and assumes, let's say, happy path, it could be a fire and forgot. The event was either processed or not, or if you were more conscious about message resilience, you could use publisher confirms and manual acknowledgement, and you could kind of guarantee an end-to-end workflow where messages are actually read by clients. And the recommendation was always to use idempotent messages, but now that you have the history of a message queue, for example, you can replay actions. You can go back in history and say that, okay, we had an outage 10 minutes ago when everything crashed in our system. Let's pick up where we left off 10 minutes ago and reapply everything, which means that you need to be conscious that the side effects of those messages are actually well understood, and again, idempotent messaging. I think that requires a different mindset. And just one more thing on that, I'm really happy that streams are not only supported by the single streams protocol, which we heard is recommended if you want high message throughput, but you can use the AMQP protocol as well with an extension, and you can match your workload. Hopefully in a sensible way that you don't use RabbitMQ as a database and the queuing system without taking care of, let's say, the disk subsystem, for example.
That's true. That's true, Gabor. Especially on the feature of just the time travel, being able just to go back and reread messages again. I mean, I think it adds so much on the resiliency and yeah, reliability of yeah, message retention. Yeah, okay. Then my next question is for Diana. Diana, so compared to classic queues, which we've had for, I think, more than 10 years now, how do streams like improve on that? I mean, Gabor has touched on some of the points, and yeah, how do streams compare to classic queues?
Well, it's not that they improve classic queues, it's that they are totally different data structure. They are meant to solve a different problem in some aspects. Yeah. When you have a stream, you have a append-only log. So it's meant as a persistent storage. You expect to store a large amount of data, and the consumers will read whenever they want, and all the stream, part of the stream. And with queues, you really want to keep the publishing and consuming rates quite similar. You don't want to create huge backlogs. You want to have high performance. String queues are also replicated by design, while classic queues, they aren't. You can have mirror queues, but that's, let's say, an extension. That came maybe 10 years ago. Classic queues has like 14, like RabbitMQ.
Yeah.
And there is a big difference also on this, as you don't delete the data. You can consume from any node, because you don't have to replicate the information. Oh, I have acknowledged this message. It has to be removed from the queue. You can read from any replica and spread the load across all the cluster without really an important impact on the performance of the writers in that aspect. That doesn't change the log. The consumers can attach to any point in the log. It's not like a queue that is first in, first out. Your consumer can decide to read from 1 week ago, 1 day ago. So that makes a huge difference. You can have multiple consumers reading at the same time on a queue, and the data won't disappear. And if they fail, they can start reading again. It doesn't matter. With a queue, once you have acknowledged a message, a classic queue, the message disappears from the system.
Yeah. Okay.
So it's a very different use case.
Yeah. Yeah.
They also have a much higher throughput, and more if you use the stream protocol. Using the stream protocol is several levels of difference with classic queues. We have some tests that, while they are a bit ad hoc, they are not like real performance. But when classic queues, you can do like 40,000 messages per second. With Quorum queues, we reach 1 million messages per second. Yeah, they are small messages. We're using batching. Everything is very optimized. But that shows that there can be a huge difference.
Okay. No, that's really cool. I think, yeah, just from hearing this, I'm getting quite excited on just using stream queues. Streams. Yeah, considering the amount of trouble of trying to get the classic queue to fit all these use cases that we've had to face. I think there's so much that's now available for us to use. Yeah. No, thanks, Diana. And then Karl, I know last RabbitMQ Summit you introduced the Quorum queues for us. Yeah. So taking the Quorum queue, which was a big step as well from the classic queue, and putting the stream implementation into perspective, how do those weigh out together?
Yeah, so Quorum queues and streams share some similarities. Quorum queues are, of course, AMQ queues. There are smart queues. They have a lot of the feature set of classic queues, and that's the way they were designed. So they're different in that sense. But they're both log replication systems, and they're both replicated by default. They're both persistent by default. So they share a lot of that side of things. Like when you look underneath, they both write to a log. They both replicate the log, and they both keep track of the replication state of the log and consider entries in the log committed as that.
Yeah.
Streams, though, mostly write messages to the log. Whereas Quorum queues write all the operations that change the state of the queue to its log. So if you enqueue a message to a Quorum queue and then you want to add a consumer, you have a command, a little entry in the log to say, I've got a consumer now and I want to be sent. I want to consume messages. Whereas in in a stream, there's no such thing. We do write other things to the stream. We can come to that later, but mostly a consumer is a separate thing that just reads the log. So in that way, they are similar. What Quorum queues does on top of its log is that it continuously calculate the queue state based on the entries in its log, whereas a stream just leaves a log there open for you to do pretty much whatever you want to do with it, as long as it's read-only. So they're quite similar underneath the hood, at least superficially similar, but obviously they are vastly different when you really look at them.
Yeah. Okay. No, that's cool. So can you say the Quorum queue is also still limited to the AMQP protocol, whereas the stream queue is a bit more flexible? We're not really fully restricted. I mean, with the
the format of the stream itself, the data format of the stream is tailored so that in order to do very high throughput. So there's no conversions going on from one message format to another message format, and then the frame format that sits on the other side. It's kind of looks the same. What the client sends and creates is pretty much what goes into the stream itself. Whereas in Quorum queues, you pass AMQP, you turn it into an internal Quorum queue message, you pop it in there, you read it out, you replicate it, all that stuff. So yes. It does a lot less work, which is why it's fast.
That is really cool. Yeah. All that mediation overhead seems to be to be reduced now. That sounds good. Okay, then back to Arnaud. So regarding the binary protocol of streams, right? What was the reasoning behind implementing a custom binary protocol for streams? And
so when we start experimenting, we had in mind to have an append-only log data structure, right? And the first experimentations was based just on a new type of queue using AMQP, but we had the storage layer, and it was optimized for throughput. It was highly optimized. So we decided to first write a prototype without AMQP at all. Actually, it started as a standalone Erlang application where we designed the first frames for the stream protocol, just to have an idea of the throughput we could get. And this is how it happened. Actually, we figured out that the protocol could stay quite simple, and we would actually get a much higher throughput by using a very specific optimized protocol. So it's like we had a very fast engine, which is the storage layer, but we could not actually use fully this engine just by using AMQP. So there are different techniques that we use in the stream protocol, which are not, available in AMQP or not meant to be used this way. So like batching, send file, all that stuff. And we have also in AMQP a lot of overhead, because AMQP has been designed for interoperability. So it's quite sophisticated. It has a lot of functionalities like channels, routing, all that stuff, but we would not need for a simple append-only log. So that's it was basically to see what we could have, and actually, to do something else than AMQP in our case, to avoid restriction from this historical protocol.
Okay. No, that sounds good. And tell me, so the stream protocol, is it something that we can even use on embedded devices, like low memory devices? Is it that reduced in scale, or I know like AMQP gets a bit too big, and
maybe we haven't tried actually. Funny story is that we used for some benchmarking and long running also benchmarking quite small VMs with only 1 gigabyte. And we got some, on the client side, we got some memory errors. We could not allocate enough memory. Basically, we had a high throughput. We were allocating a lot of memory just for network communication. And it was too much for these small VMs. They were the JVM also, which was on the Java client side, was so maybe too much pessimistic in terms of allocation. So it was working, but it was so fast that the allocation will actually saturate the memory of these small VMs. I guess it's possible to try it on very small devices, as long as you don't expect hundreds of megabytes per second of traffic.
There is, if I can just add something about that, there is one slight problem with using it in that sense, using the stream protocol for that, because the stream protocol reads, we call them internally, we call them chunks, which are batches of messages, and they read them chunk by chunk. And if it happens that the stream that it wants to consume from has large chunks, contain large chunks, it will get the whole chunk, and that an embedded device might not be able to cope with an entire chunk. And a better device needs, doesn't need high throughput messaging typically. If it does, it probably should be spending its CPU power doing something else, like something useful. So it probably would be better to use an IoT protocol for that, and then extract the individual messages from the stream and kind of use them instead, as AMQP would do if it consumed from a stream.
Okay, no, that's nice, good to know. And staying with you, Karl. So in terms of the client libraries, I know yesterday he mentioned that the Java client is quite stable, and there's the Go client, which is currently a work in progress, but it's already in use. So what's like the roadmap for the client libraries? Are we expecting to see a lot of work going into these? And
we hope so. Obviously, we're not a huge team, although we're bigger than we ever been. So we'll need to prioritize things in order. I think we're going to tackle .NET and Python pretty soon. Both those languages. Obviously, wrap up the Go client, make sure that's production quality, and then .NET and Python. Other languages may follow as they fit in, but the protocol isn't particularly difficult to implement. There aren't that many frames. It's very, as Arnaud has explained, it's quite simple. The only complicated part is that the messages themselves are AMQP 1.0 formatted. So if you write a client for it, you typically will have to grab an AMQP parser and generator in order to best format messages, at least for interchange. But there's good resources, and I think we're going to try to prepare some more resources for it as well, so that if it's not .NET and Python you're waiting for, if you're waiting for something else, maybe pick up your editor and
and start coding.
Do get in touch if you're planning that. We certainly would like to help anyone wanting to kind of contribute, and coordinate that with us.
Okay. All right, cool. I think my next two questions you guys have already answered. Then my other question, I guess that's for Diana. So features like message TTL, queue TTL, expiry, dead lettering, priorities, like, are we going to be able to take all those features which we're now so used to using with the classic queues and some which are supported in Quorum queues? Are we going to be able to use that with Stream?
Well, some of those features doesn't make sense semantically. So if when you consume a message, you don't reject or remove it from the queue, why you are going to dead letter it? So that's something that I don't see a reason to implement, for example, because what do you do? Nothing. Things that are message TTL, well, we have something similar that are the retention policies, because the string could grow forever. So you can decide that you want to only keep one message of 1 month of data, 1 week of data, or things like that. So it's not exactly mesastTL, but it works kind of similar.
Okay.
For the Qt2L, well, why do you want to delete the queue after a certain amount of time? So it's meant to store data for a long period. They are not short-lived queues in general.
Okay.
So it's again this semantically we don't have really a good use case for that. And also this kind of auto-delete queues have other issues. Also priorities, for example, you could implement them with several streams, one per priority. So those that you have mentioned are features that initially they are not going to be part of the stream queues.
Yeah. Okay. Okay. No,
but it's not that we don't want to implement it, like why you are going to implement them.
Yeah. 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 I mean, I think similar. So it kind of reminds me of some cases with the lazy queue, where you get like these lazy queues just growing to some massive size and using up so much disk space. And at some point, maybe someone would want to just have that dropped automatically by RabbitMQ. But again,
but you have retention policies for that, so you can configure them in that way.
Okay. Okay. No, that's cool. So that is supported.
You can decide, by time or by size.
By size.
What do you want to keep?
Cool. Yeah. Okay. Okay. No, that's nice. Yep. And then just getting a bit on some of the lower level aspects of streams. I think Arnaud did mention that there's the new streams protocol. There's the MQP protocol, which is still supported. So in terms of the default port for streams, Arnaud, so what is, because we know port 5672 like off the top of our heads for MQP. So what's the default port for streams?
So it's 5552.
5552. Can we get that allocated with ANA or?
No, actually we I think the first default port was 5555, but it's because it was the default port on the Erlang range library, the TCP acceptors library that we use.
Okay.
But this one was actually already in use, so we just chose to use 5552, and this is for the plain connection, and there's 5551 for TLS for streams. So it's just an extra plugin in the core distribution that will start a listener on 55 and 52, and it's obviously you can change the port if you want to.
Yeah, from config. Okay. No, that's nice. And then internally, in terms of, I guess the new plugin introduces a new socket reader Erlang process, right? So in terms of the implementation, is that I know the current implementation is like a customized. The Rabbit reader is like a custom finite state machine, which is reading from the socket. Is that the same with what are you using there? Is that
so for just for the TCP part, it's range. So this the Erlang acceptor library. And it's quite simple. We just basically read data from the socket. So there's no Rabbit reader, just like for AMQP and over. It's not using the same mechanism as the over socket handling, if I remember correctly. So you just open a TCP connection, and then the authentication phase, the connection opening is a bit like AMQP with the same kind of faces, because we decided it was good enough. And it was also easier for us to actually make sure that we will support the same authentication mechanisms and so on.
Oh, that's nice.
So the authentication steps are pretty much the same as in MQP 091.
Okay, no, that's nice. So we can still have the maybe authenticating against LDAP and then pulling back to the internal.
It fully integrates with the existing authentication infrastructure. So all the backends are still valid and so on. So it just builds on top of the existing infrastructure for this. So there's no difference from from the other protocols.
Yeah. Okay. No, that's nice. That's good to know. Yeah. And Karl, in terms of message storage, just in a nutshell, how is that carried out with streams?
Right. Okay. So in a nutshell, it opens the files and then it writes records to the file until the file reaches a certain size, and it stops writing that file and start writing to another file.
Okay.
And that's it. It's a little bit more complicated than that, of course. Internally, we have a kind of like a sort of a writer sync that kind of absorbs all the incoming messages one by one and kind of batches them up into batches. Creates this chunk format that I spoke about earlier.
Okay.
And that is what each write to disk is one of these chunks. It writes one of those chunks, and it does some accounting work, and then it stores that. So a chunk is a bit of header information, and it is a list of messages.
Okay.
In RabbitMQ. And some of these messages are special messages. Some of these messages are what we call sub batches. They are actually batches of messages inside the batch of messages. And I think Arnaud spoke a little bit about them yesterday. That's when you're really push through a lot of data, like lots and lots of data. So that on the client side, the client would build this sub batch, which is a batch of messages, and send that as a whole piece of binary, and we'll take that. And if there are 10 messages in that, we count 10 messages in the throughput, right? Because it's 10 messages, right? We also have some options around that for client-side compression, but they are which it supports. It's all client-side stuff. The broker doesn't do anything with that bit of data, so you can actually compress that batch of messages, so it becomes smaller. So that's it. So it writes them to segmented storage, and these segments are by default at about half a gigabyte of in size. So when we reach that size, we'll start another one, and it's named with the first offset. So each message is assigned an offset in the stream. And that we use that offset to name the segments. It just keeps doing that. Every now and again, it will evaluate to see if the stream has become too large, or the messages in the oldest segment are too old. And when they are, it will delete the segment from the oldest segment as part of its retention policy. So it will follow the retention policy, which can be either by size or by age, as Diana mentioned. So everything happens at that level. Everything happens at the segment level. The replication and consumption is all at the chunk level, which are the individual pieces that make up a segment.
Okay. All right.
And that's it. And interestingly, maybe worth mentioning, we don't f-sync the file at all.
Okay.
We leave that to the operating system. Because it's when you have many streams, all of a sudden you now have a problem where you need to synchronize f-syncs and stuff like that. If you need that degree of safety, I mean, you're still replicating, right? So you still got this data on multiple nodes, and so you still got very, very, very good data safety. But if you need that extra level of data safety, then you want to use Quorum queues instead, because they f-sync everything before they confirm entries and stuff like that.
Okay, cool. So that brings me to my next question. Like, so in terms of partition handling, and I know with Quorum queues you've got the whole log and commit, and so how do streams handle that now?
You want me to take that one as well?
You can take it. You and Diana.
Okay, Diana, do you wanna? Okay. So streams are coordinated. They are coordinated and monitored by a coordinator subsystem, which is implemented as a Raft machine, just like Quorum queues are. So that will detect when a stream member goes down, particularly if it's a stream leader, because obviously you can't operate without a leader. and it will perform an election process and restart the stream system in a better state, hopefully.
Yeah.
Streams are quorum systems, worth mentioning.
Yeah.
So when you publish a message to a stream, you will get to confirm when a quorum of stream members have confirmed back to the leader process that they have written the entries to disk.
Okay.
So it's just like, it's got exactly the same kind of semantics like quorum queue. So that's another thing to bear in mind.
Yeah. Okay.
Ayanda, do you want to add anything on top of that?
No, I think that's perfect.
Okay, no, that's cool. I think, yeah, I think in terms of safety, data safety, yeah, I think, yeah, the whole Raft approach is just making things so much, yeah, data safe. Yeah, okay. And then, okay, another question while we're there, in terms of the overhead of replication, is that a lot or is it not much? No.
For me again?
In terms, yeah, for you again. Yeah, I mean,
okay.
yeah.
So I think Arnaud has already kind of covered how the replication happens, but there isn't a lot of overhead.
Yeah.
I mean, it depends on what you mean by overhead. Obviously, it uses a network quite heavily, and it's able to use a network quite heavily. But what happens is that we you know, these chunks that we write to a stream, they get read by an underlying process, and typically we would use send file, so we wouldn't even leave the kernel to read the data into userland and then send it out socket. We would just send it straight from the kernel over to the other side, to the other Rabbit node, whereas they will be accepted and written to disk as soon as possible. So memory overhead is negligible. Obviously, it is able to use a lot of disk and a lot of network if you really make it.
Yeah.
It makes good use of the resources that are available.
Yeah. No, that's nice. That's nice. Okay. Yeah, and then back to Diana. In terms of the plugins which are currently supported, I know we use the Shovel and the Federation plugins quite a lot. You know, especially across different data centers. Are we going to be able to do the same with for streams?
Well, once again, streams are not queues, so they behave a bit different. At the moment, Shovel supports the streams, but we don't move messages. You only copy messages. Because you don't delete things from a stream. It's an append-only log.
Yeah.
So you can use Shovel and you get a copy of your stream.
Okay.
Regarding Federation, no, we don't support Federation. But it's an use case that really doesn't make sense, because if you think about Federation, you move messages when the consumers move from one cluster to another. We are not going to move, we are going to copy. So what do? We copy now 100 messages. In a bit, we'll copy 500 messages. You're not really copying a full log. You will be copying bits of the log.
Yeah.
And then your consumers could attach that other cluster and read small bits of the log, but they will never get the whole sequence. So by design, it doesn't make sense unless someone show us a real use case that, okay, we really need Federation for this and makes total sense. Initially, Federation is no. If you want to copy your log, you can use Shovel for that.
Yeah. Okay. No, thanks. Cool. Yeah. So to everyone listening, so if you want Federation support, just go on Git and just open an issue.
With a good use case. You have to convince us of that.
We have to convince you. Okay. No, that's fine. And in terms of matrix, Diana, I know you've done a lot of work with the matrix as well. So what matrix can you expect to, like the main matrix that we expect to see on regarding streams?
Well, the management will support still the same metrics as other queues, but metrics that obviously make sense. For example, string queues, they don't keep any messages in memory. So there won't be a counter for that. That will simply disappear. So we streamline the things that doesn't make sense. So you don't have zeros or things like they are not relevant for string queues.
Yeah.
But for example, we export in Prometheus new metrics, and we have Grafana dashboards for the new global metrics, where you can see all the publishers, all the consumers, if you use the stream protocol, and also counters for all the errors of the protocol, because the stream protocol defines a series of standard errors.
Yeah.
So now you can know how many errors you have in your system of that kind, which is quite cool, because in general, we don't report these kind of things.
Yeah.
So now you can know if a subscription doesn't exist, a subscription ID, if the authentication failed, this kind of stuff. So you will have individual counters for each type of error.
Yeah.
There is also a new management plugin for streams, where you can have the details for the connections for the protocol.
Yeah.
As using the stream protocols, the connections are different. You can also see again the consumers and the publishers. And the big difference with classic queues or quorum queues is that now you can list the publishers, because publishers have to subscribe to register or unregister. So now you can see how many you have and from which connection do they come. So that's a big difference, because before you only had consumers, but now you also have publishers. And you can also see all the details of the connection, the rates, the heartbeat, the configuration of the authentication, name of the connection. So you have more details. If you click on a connection that belongs to the stream protocol, will bring you to this page that is very similar, but more detailed.
Yeah. Okay. No, that's nice. And I'm sure we can still translate all these metrics to tools like Prometheus and Grafana. And,
yeah, we already have them on the Prometheus plugin.
Yeah.
So you can consume them from there.
That is awesome. Yeah. Okay. Thanks, Diana. And last question. I'll ask Arnaud and Gabor. But yeah, first with Arnaud. In terms of the stable release, which we can take streams to production environments. I know usually with the major release of RabbitMQ, we usually wait just a bit for a few patch releases. But yeah, which version should we expect to be safe to take it to like critical production environments?
Yeah, it's a tough question. We we expect it to be production ready for 3.9.x. Basically, but we need some more feedback from the field, basically from the community. We tested a lot, but not with production workloads. We have been running long-running tests on some cloud instances and so on, and we found bugs, things to improve. But I think it's ready if your company has I don't know, some non-critical workloads. They could start using them for they can start using Stream for them. Like every company has always some kind of distributed logging application that could be a good fit for this kind of applications first.
Okay.
Basically.
All right. Cool. So basically, 3.9.0 is ready to take it to production.
Yeah.
All right. Okay. Cool. And Gabor, from your side, I know you've got quite a lot of opinions on this, but in terms of, I know some of the clients that you work with are listening in here. How soon are you going to start recommending streams?
Yes, I have an opinion. I usually don't recommend anything that ends with .0, any version, because that is always cutting edge. But I'd like to say that I would recommend anybody who's interested in streams to try it out, because you can never underestimate how creative people are to break things when you put it into different use cases. So I always recommend being very conservative, putting things into production, but very optimistic, trying things out in test environments, trying to put their workload stress, testing out different resiliency strategies. And I think with streams, it's even more extremely important to test this out, because with queues, the usual saying is that an empty rabbit is a happy rabbit. So you try to keep your queues usually empty. Things are flowing through, but with streams, you start accumulating quite a lot of data over time. So it's even more important to make sure that testing is done properly on any kind of customer deployment. And I do trust the testing of VMware. They usually do quite a good job, but there are just so many different use cases out there that nobody can prepare for all these edge cases.
Yeah,
but
no, that's true. That's true.
As we see, in less than a year, they made Quorum queues production ready. We started recommending it soon after it was released in some workloads, and nowadays this is the default option. So I see no reason why we shouldn't trust streams.
Yeah, no, that's cool. That's cool. I think there's so many good things that are available with streams. I mean, I'm feeling like I don't even need to use a load balancer with the smart clients when I'm using streams. But yeah, that's yeah. Okay, no, that's cool. Then there's some questions. Yeah. I think we're running out of time, but I'll try and run through them quickly. So the first question is from Matt Davey. It says, massive throughput within the broker is wonderful, but only half the story. We need to scale out our consumers to match. Can the workload be distributed amongst multiple consumers? I think, I cannot imagine a single consumer handling 1 million plus miss. Yeah, I think from yesterday's talk from Arnaud, you said the next, part of the roadmap is to have competing consumers, right? So yeah, that is definitely coming up. Then the next question, what are the options for replication between clusters since the consumer offsets are written to the log? Does that mean that a consumer could easily switch to another cluster with a replicated stream? Karl, I think you touched on that as well, right? And Arnaud,
I think I know, Matt, and it's a definite yes. Yeah. You can definitely do that, and in fact, for very high throughput scenarios, we do recommend that you attach your consumers to a replica rather than the leader, because the leader does more work, it does all the writing work and all the calculation work, whereas you get more space to just read in your own. But so you can attach to any member, any Rabbit node that has a member of your stream, whatever that member is, you can read from it.
That's a huge improvement, because that eliminates the extra hop which consuming on classic queues, for example, always has to be incurred.
I mean, you'd always want to consume. I mean, in fact, you can't consume from a node that doesn't have a stream member, right? You will get an error. But also, it will allow you to scale your consumers when we get the competing consumers feature in, because that's a feature that fits very well with the existing kind of Rabbit patterns. And then you can spread your consumers across the cluster and really blast through that stream at good pace.
Okay, no, that's cool. And then maybe we can squeeze in a couple of more questions. What is the advantage of using RabbitMQ streams over a dedicated event store database? I think
let me try to answer that. I always find that the biggest advantage of RabbitMQ is its versatility, that it supports a lot of different use cases, and now it also supports streams. So if you use a queuing system, if you need some queues, then for another use case, you need streams. I find that for a lot of use cases where the load is not that heavy, then these can coexist in the same system. So why maintain two different systems, which sometimes requires multiple nodes, they all require several nodes to be set up. If you already know how to manage your RabbitMQs, then it's out of the box, it's supported. You just need to enable a plugin.